There's a story happening right now that most of us are completely missing. While all the headlines are screaming about one kind of technology, another one, something much bigger, is quietly rewriting our entire future. And today, we're going to pull back the curtain on it.
So let me ask you this. What if the single biggest leap in computing history just happened and it barely made a whisper? I mean, think about it. We are all absolutely glued to the spectacular fireworks show that is artificial intelligence, right? But what if, behind all that noise and light, the actual rocket that's going to take us to the next age of technology just silently lifted off?
Right, so here's the deal. The public story, the one we all see, is 100% focused on AI. And hey, for good reason. It's incredible, it's tangible, it's right in front of us. But there's this hidden story, this other current running just beneath the surface. Let's just imagine that sometime in late 2024, something truly fundamental changed in the world of quantum computing. We're talking about a foundational shift, a whole new chapter for computing itself.
Okay, so let's start digging. First, we really need to get our heads around the sheer scale of a leap like this and why all the old assumptions, all the old timelines, they just might not apply anymore. Because a breakthrough of this magnitude, it would just shatter the established timelines. You know all those articles you've read, the expert reports that say practical quantum is coming in a decade? Poof, gone, instantly obsolete. It means something happened that basically hit the fast-forward button on the future.
And this is the absolute core of it, right? For years, the story's been the same. Quantum is coming, eventually. It's always been this distant promise, always 5, 10, maybe 20 years down the road. But in this new scenario, that's not the reality anymore. A fundamental roadblock, the one thing that was keeping quantum computing locked away in research labs, has just been cleared.
So that's the big question, isn't it? What exactly was this barrier? And why would solving it change literally everything? Let's decode this breakthrough. The key to this whole thing has a pretty technical name: quantum error correction. But stick with me, because the idea is actually pretty simple. Think of a quantum computer like a superpowered, hypersensitive race car. It's unbelievably fast, but it's also unbelievably fragile. I mean, the tiniest vibration, the slightest change in temperature, and the whole calculation just veers off track and crashes. Quantum error correction, well, that's the genius bug fix. It's the suspension system that finally makes these machines stable, reliable, and ready for serious work. It was the one piece of the puzzle that was missing. And once you have that, well, the dominoes start to fall, and they fall fast. First, you solve error correction. That means, second, the calculations become trustworthy. And when they're trustworthy, you get to the third, most exciting part. You can finally unleash these powerful machines on problems we've only ever dreamed of solving. And believe me, we are not talking about small problems. We're talking about designing new medicines at the molecular level, untangling the chaos of global logistics, creating revolutionary materials that don't even exist in nature, from the atom up, building climate models so hyper-accurate they could change policy overnight. This stuff stops being science fiction. Suddenly, the door to solving it is kicked wide open. Okay, so if a breakthrough this huge really happened, why the silence? Why isn't it on the front page everywhere? Well, because the proof isn't going to be some flashy press conference. No, you'd have to follow the data, because behind the scenes, a quiet race would have already begun. Exhibit A, the patents. You'd see this sudden, frankly unusual, surge in patent filings for quantum error correction, say, around early 2025. This isn't just normal R&D. This is a gold rush. This is companies scrambling to own a piece of this newly unlocked territory. Then you'd have to look at who's doing the buying. It wouldn't just be the usual tech giants. You'd see major pharmaceutical companies, biotech firms, quietly snapping up these small, specialized quantum startups. Why? Because they know this tech is about to revolutionize their industry, and they're making their move before anybody else notices. And you know the saying, follow the money. And the money would tell the story. Venture capital would just pivot hard. You'd see all that funding shift away from theoretical, let's figure it out, research and just pour into startups that are building actual, real-world applications. That's the market betting big that the time for quantum is now. And this is where things get really intense. A new urgency kicks in. That whole idea of quantum-safe encryption, it would stop being a someday problem and become a right-now crisis. With reliable quantum computers on the horizon, every piece of encrypted data, from government secrets to your bank details, is suddenly vulnerable. The race to secure our digital world would go into absolute overdrive.
So let's connect these dots. The patents, the quiet acquisitions, the money pivot, the security scramble. What does this all mean? In this new world, what does our quantum reality actually look like? Well, it means the future just got yanked right into the present. That old forecast of quantum arriving around 2035, that's history, ancient history. The new reality is that the starting gun has already fired. We are not waiting for the race to begin. We are in the race, right now.
The long-term impact is just staggering to think about. We'd be on the cusp of entirely new industries, whole new kinds of jobs. We'd have potential solutions to some of humanity's biggest questions, from climate change to disease. This isn't just about a better computer. It's a new fundamental tool for civilization, and it will absolutely shift the balance of power and redefine what's even possible. So a silent revolution like this probably isn't a matter of if, but when. And it might not announce itself with a ton of headlines. It could already be here. Which leaves us with the biggest question of all, one that goes way beyond the technology. The real question is for us. Are we ready for what comes next?